So in this lecture, you are going to see types of bonds. In last lecture, few concepts we have discussed. Let me revise those concepts. We are talking regarding atom carbon. Carbon is represented with the letter C. Its atomic number is 6, mass number is 12. And while coming to its valency is 4. While coming to its electronic configuration, you can write either 1s2, 2s2, 2p6, or simply you can represent it as 2, sorry, not 2p6, it is 1s2, 2s2, 2p2, 2p2, or you can represent 2, 4. So this 2 is regarding first orbit 1s2. This 4 is related to second orbit 2s2, 2p2. And to get stable, this carbon cannot lose electron, cannot gain electron. Instead, it will go with sharing of electrons. Sharing of electrons, that bond means combining with other atom. Whenever you see bond, the word bond is nothing but combining. If one atom is combining with another atom, we can say one atom is bonding with another atom. That is the technical word we have to use in chemistry. If two atoms are combining together, why it will combine? We know, to become stable. To become stable. Now, sharing of electrons. This type of bond is known as covalent bond. Now, few things you need to keep in your mind. First, let us try to understand this carbon. Guys, carbon, its electronic configuration is 1s2, 2s2, 2p2. You need to represent its electron dot structure. So whenever they are saying electron dot structure, you can remember your ninth class thing, ninth class diagram. This is nucleus and this is first orbit, this is second orbit, and how many electrons you need to represent. Just if you observe that electronic configuration, this one will represent orbit number, this 2 will represent electron number, electrons count. Now, how many orbits carbon has? 1 means first orbit, 2 means second orbit. So 2 orbits we have drawn. And in first orbit, how many electrons? 2. Here there will be 1 electron. You can represent with cross. Electron you can represent with cross. Sometimes you can represent electrons with dot. Both are correct. You can play tic-tac-toe. In that, cross and circles will be there, right? Like that. Cross is a representation for electron. At the same time, small dot is also representation for the electron. Either way you can represent. So 2 electrons in first orbit. While coming to second orbit, this total you have to consider as second orbit, or you can consider this one as valency orbit also. And how many electrons are present? 2 plus 2. You have to add. 2 plus 2 is 4. 1, 2, 3, 4. This is electron dot structure of carbon. And make sure while you are representing 2 electrons in first orbit, there should be same space, I mean equal space. And these 4 electrons also, there should be exactly equal space between electrons. Next. Now, electron dot structures is not important in your 10th class to draw bondings. To draw bondings, we should not consider electron dot structure. This is just for your information. I have drawn. We are not drawing any electron dot structures. Okay. we need to draw structures representing bonds or representing valency electron. So we need to draw structure or represent atom with valency electrons. Now, while coming to carbon, how many valency electrons are there? Carbon has 4 valency electrons. Now, once if you observe its electronic configuration, it is 1s2, 2s2, 2p2, isn't it? Now, to become stable, every atom, to become stable, every atom should acquire octet electronic configuration or should follow octet rule. What is octet rule? 8 electrons in outermost orbit. So if they ask you what is meant by octet rule, you have to say 8 electrons in outermost orbit. If you see this carbon, this is outermost orbit, isn't it? 2s2, 2p2. How many electrons it has? 4. Still it need 4. I mean, it should become 1s2, 2s2, 2p6. So this is outermost orbit. 6 plus 2, that is 8, isn't it? If any atom is becoming, if any atom has octet rule, then we can call it as stable. Not only 2s2, 2p6, guys, in 9th class what we have learned? 8 electrons in outermost orbit means ns2, np6. Here, n represents orbit number. Exemption is there, except first orbit, isn't it? Now let us check whether all stability elements are following it or not. What are stability elements? Helium, neon, argon, krypton, xenon and radon, right? Helium atomic number is 2, neon atomic number is 10, argon atomic number is 18, krypton atomic number is 36, 54, 86 we have. Let us check this. Helium, if you write electronic configuration, it is 1s2. Neon, if you write electronic configuration, it is 1s2, 2s2, 2p6. If you count 6 plus 2, 8, 8 plus 2, 10. 10 we got. For argon, if you write electronic configuration, it is 1s2, 2s2, 2p6, 3s2, 3p6. If you count first 2 plus 2, 8, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18. 18 is the atomic number. Now if you write for krypton, it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6. So 3d10 is up to zinc and 4p6. Now if you observe 2 plus 2 4 plus 6 10 plus 2 12 plus 6 18 plus 2 20 plus 10 30 plus 6 36 is the atomic number. Atomic number of krypton. Now what I told you, what is octet rule? Outermost orbit should end with this structure ns2np6. ns2np6. In the place of n, what we can substitute? Orbit number 2, 3, 4, 5, like that. Orbit number. Of course, 5 will not come. Up to 4. Up to 4 only we will get. That also we have discussed in 9th class. Why? That also, okay, yeah, after completion of this lecture, if possible, I will tell that. Now, except first, for helium, we cannot go with 1s2, 1p6 because First orbit, we have only one orbital, s orbital. And while coming to second, if you substitute 2, it will become what? 2s2 2p6, isn't it? Now you can observe 2s2 2p6. If you substitute 3, what will happen? It will become 3s2 3p6. If you observe 18, 3s2 3p6. If you substitute 4, it will become 4s2 4p6. You can observe 4s2 4p6. What you can expect from for xenon? Definitely outermost orbit will be 5s2 5p6. Yeah, here 5 6 yes. Here you can get for 5 6 up to 7. Up to 7 we will get. We won't get for 8. 1 and 2 is exemption. And for radon, what can we expect? 6s2 6p6 we can expect, isn't it? That is the thing. So once again, you see, carbon has 4 valency electron. To become stable, carbon should satisfy octet electronic configuration. Octet rule or octet electronic configuration means 8 electrons in its outermost orbit. So simply to say, carbon from 1s2 2s2 2p6, that should become 1s2 2s2 2p6. From 1s2 2s2 2p2, it should become 1s2 2s2 2p6. Or simply to say, 4 electrons should be given to the outermost orbit, but it will not gain, it will share. Let us try to understand that. Carbon, if you draw valency electrons, how many valence electrons we have? Here if you observe this one, 2 and 2. 2 plus 2 is 4. So we have to represent 4 valency electrons. What I told you, here one valency electron, here one valency electron, here one valency electron, here one valency electron, 4 valence electrons. You can represent like this also. 2 electrons here, third electron, fourth electron. According to the bond, you can do it. Or you can represent like this. 1, 2, 3 electrons here, 1 electron here. According to the bond, what I told you, single bond, double bond, triple bond. I'll explain you this in this lecture. Now, from now, one thing should keep in your mind. In this chapter, we are going to draw diagrams like this. Carbon, C. How many valencies? 4 valency. Here, there is one electron, isn't it? Always this electron will be trying to get another electron here, such that this side it got paired. And here this electron will be trying to get another electron here. This electron will be trying to get another electron here. This electron will be trying to get another electron here. Now you see how many extra electrons got? 4. That's what we have discussed here. It needs 4. 4. So 4 it got. Now, when 2 electrons are combining, when 2 electrons are bonding, when 2 electrons are near to each other or bonding, you need to draw a line joining 2 electrons. You should draw line joining 2 electrons like this. Like this. Now consider we have 1 electron here, 1 electron here, and we don't have any 2 electrons here. Still it is waiting, let us assume. Then what you can draw? You can draw only 2 lines because still there is no bonding. That is the thing, you have to keep it in your mind. And here, whenever you draw a line, it has 2 meanings. Whenever you draw bond line, it has 2 meanings. First meaning is, there is an electron, it is waiting for extra electron. It is waiting. That is one meaning. Another meaning, if you draw a bond line, meaning is there are 2 electrons at both ends. So either way you can consider. Either way you can consider. Fine. Now you see, from now, carbon, how many valence electrons? 1, 2, 3, 4. What is the meaning for this? Carbon has 1 electron at this end. It is waiting for another electron here. Carbon has one electron, valency electron here. It is waiting for extra electron. It has one electron here and here. It is waiting for extra electron. That is the meaning you have to remember. Okay, how to represent bondings? Carbon always 4, but places your wish. Carbon 1, 2, 3, 4 means 4 valency, or carbon 1, 2, 3, 4, 4 valency, or carbon 1, 2, 3, 4. That is also correct. Carbon 1, 2, 3, 4. This is also correct. Carbon 1, 2, 3, 4. That is also correct. Or carbon 1, 2, 3, 4. Whatever structure, no problem. If you want to represent triple bond, that also possible. 1, 2, 3, fourth valency. Or carbon 1, 2, 3, fourth valency. Carbon with 3 valencies and fourth valency. Like that, whatever it may be the direction, whatever it may be the place, you can represent. Now, while you are representing these bonds, only one thing you have to remember, there are 4 electrons, valency electrons. It is waiting for extra 4 valency electrons to get stable. That is the concept you have to understand. So, carbon symbol is 6, atomic number is, carbon symbol is C, atomic number is 6, valency is 4. Electronic configuration 1s2, 2s2, 2p2. This is valency electrons or outermost orbit. So outermost orbit has 4 electrons. Still it needs 4 electrons to get stable. To get that, it will share electrons. That bond is known as covalent bond. Bond is nothing but combining of electrons to become stable. Why it will combine means, why it will bond means stable. Electron can be represented using cross mark. Electron can be represented using dot. Now this is electron dot structure. This is not the structure you are going to draw in your 10th. You are not drawing this. Now, so carbon 1s2, 2s2, 2p2, 4 electrons are there. Still it needs 4 electrons to become stable. Every atom will be trying to acquire octet electronic configuration. Octet means 8 electrons in outermost orbit. So that octet formula is Ns2np6. Whatever stability atom you take, helium, neon, argon, krypton, xenon, radon, these 6 stability atoms will have Ns2np6 as outermost orbit. Now carbon, from now what we can do, we can represent 4 valencies by using lines. Each line will represent 1 valency electron. So there are 2 meanings I told. First meaning, 1 electron is present at this end, waiting for extra electron at this end. Or second meaning, you can draw line when 2 electrons are bonded. So however you want, you can represent single bonds, double bonds, triple bonds. More than that, you should not represent. So we have seen how to draw structures, how to represent valencies. Now let us try to understand single bond. What is that single bond? Single bond is nothing but, if you observe any bonding between 2 atoms, there will be only one single bond. I mean, only one pair of electrons. You can find only one pair of electrons. That is the meaning of single bond. Example, we'll take hydrogen. Guys, hydrogen H is atom, but in reactions, chemical reactions, we will be taking H2, isn't it? H2 is an element. Now, how this H2 is formed? First, hydrogen, its atomic number is 1. If you write electronic configuration, it is 1s1. It is not stable. To get stable, what it will do? It will try to get 1 electron such that it can become 2. 2, nothing but helium electronic configuration. Now, 1 electron, if it is gaining, let us assume, if it is gaining 1 electron, there will be only 1 proton. It cannot handle 2 electrons. Of course, mass of the proton is huge. Of course, mass of the proton is greater than the electron. 2 negatively charged particles cannot be tolerated by 1 positive charged particle. So hydrogen will not gain. what it will do? Hydrogen will share its one electron with another hydrogen. So we have another hydrogen atom with atomic number 1 with electronic configuration 1s1. Now if you draw valency electrons, hydrogen here we have which has one valency electron, isn't it? We have another hydrogen which has one valency electron. I told you, right? Electrons you can represent by using cross mark or dot mark. Now what it will do, you know, this hydrogen will share its electron with this hydrogen's electron. This second hydrogen will share its electron with first hydrogen electron. Now this hydrogen will bond like this. So electron is shared, na? So it will be with this hydrogen, and this hydrogen also got this electron. So you can draw another circle here. Yes, you can draw, or I'll try to draw using this. So this hydrogen will share this one, and this hydrogen will share this, both. Fine. Like that, both hydrogens are combining together. And here you can observe this, you can write it as hydrogen plus hydrogen gives rise to H2, and this one you can draw like this also. Hydrogen has one electron plus it is combining with hydrogen with another electron, gives rise to hydrogen with one electron, hydrogen with another electron. This hydrogen is combining with this electron, this hydrogen is combining with this electron. Between two electrons, what we have to represent? Bond. How many lines you can draw? Only one you can draw, isn't it? So you can write hydrogen bond hydrogen. So in between hydrogen, how many pairs are there? Only one pair. One pair means only two electrons, only one bond. So that is single bond. Now double bond, let us discuss. Now you might have got idea. Double bond. Double bond means simply to say two pairs of electrons. This you can observe in oxygen. Oxygen symbol is O, that is atom. If you represent O2, that is element. Now oxygen, its atomic number is 8. Electronic configuration, if you write it, is 1s2, 2s2, 2p, 4, isn't it? 4, 5, 6, 7, 8. Now how many electrons it needs to become stable? 2. It cannot gain. It cannot gain because 8 protons cannot tolerate 10 electrons. So what it will do? It will combine with another oxygen with the same atomic number 8 with the same electronic configuration 1s2, 2s2, 2p4. Now while coming to the outermost orbit for this oxygen 2s2, 2p4, while coming to outermost orbit for this oxygen 2s2, 2p4. How can you draw? First oxygen with how many outermost electrons? 4 plus 2, 6. 1, 2, 3, 4, 5, 6. We have another oxygen with the same valence electrons, isn't it? 1, 2, 3, 4, 5, 6. Now what will happen? This electron will combine, will share, will bond with this electron. This electron will bond with this electron. Now you can expect a bond like this for this oxygen, and for this oxygen also you can draw like this. Now try to count number of electrons in circle. 1, 2, 3, 4, 5, 6, 7, 8. In the circle, 1, 2, 3, 4, 5, 6, 7, 8. 8 means octet. Now this 6 has become 8. This 6 has become 8. Now 8 plus 2, 10. 8 plus 2, 10. Stable. Like that. How you can draw? Oxygen plus oxygen gives rise to oxygen element. Or you can draw like this. Guys, this you can draw. How you can draw? Oxygen, double bond, oxygen. Simple. No need to draw all these cross marks. Okay. Now triple bond. This you can do it, I think so. Triple bond. Triple bond means there will be 3 pairs which you can observe in nitrogen. Nitrogen. Its symbol is N. Its atomic number is 7. If you write electronic configuration, 1s2, 2s2, 2p, 2 plus 2, 4, 4 plus 3, 7. Now, this nitrogen will combine with another nitrogen with the same atomic number with the same electronic configuration, 1s2, 2s2, 2p3. Now, what is the outermost orbit? 2s2, 2p3. For this, 2s2, 2p3. Now, if you draw nitrogen, here we have another nitrogen, and while coming to electrons, 3 plus 2, 5, right? 1, 2, 3, 4, 5, or don't draw here, draw it here. Now 1, 2, 3, 4, 5. Now what will happen? This electron combines with this electron, this with this with this, and we will get one bond here, and we will get here, isn't it? So now if you count number of electrons, 1, 2, 3, 4, 5, 6, 7, 8. So for this nitrogen, instead of 5, it got 8. For this electron, sorry, for this nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. Instead of 5, it got 8. 8 plus 2, 10, got stable. Like that, it is formed. And if you want to draw, how can you draw? Nitrogen with 3 bonds. So now we have understood. So hydrogen, single bond, oxygen, double bond, nitrogen, triple bond. So single bond means 1 pair of electron, double bond means 2 pairs of electrons, triple bond means 3 pairs of electrons. That's it. In our next lecture, we are going to discuss how carbon will be combined with different atoms to get stable. Let us see all covalent bonds. We will see structures, different examples of covalent bonds.